And now going over root mean square propagation. Root mean square propagation is an adaptive learning rate method designed to resolve the radically diminishing learning rates commonly in autograd. So it's an adaptive learning rate improvement from autograd. And it does so by modifying the general gradient descent by dividing the learning rate for a weight by a running average of the magnitudes of recent gradients for that weight. So modifies the general gradient descent and by dividing the learning rate for a weight by a running average. So learning weight. For a weight. By a running average of the magnitudes of recent rates. So recent running average, or running average of recent. Gradients. For the same weight. This means that the algorithm divides the learning rate by an exponentially decaying average of the squared gradients, hence the square root. And this operation prevents the learning rate from decreasing too fast. Prevents learning rate from decreasing too fast. And is beneficial for problems with very noisy / sparse gradients. So very useful for noisy / sparse gradients. And root mean square propagation can work well in scenarios where autograd falters due to aggressive and monotonically decreasing learning rates. So we got a good speed of learning rates. For higher accuracy. And to go over the symbols for root mean square propagation. The following symbols we have will be, we have e of g squared with the absolute value with respect to time. Which the running average of the square gradients. And then we have mu. We have the following symbol, as we know, which is the learning rate. Then we have epsilon, a small constant for numerical stability. Constant for numerical stability. And G of t which equals the gradient of the loss function with respect to the input vector at a given step in time. So gradient of a loss function with respect to the input vector represented by theta at time step t. What is... Alright, there we go. Now let me just clean this up. There we go. And let's move over to our next part, autograd. And so yeah, thank you very much for taking time to watch this. If you found this video helpful, be sure and feel free to please like and subscribe. And if you have any other questions, feel free to put it in the comment section. And as always, take care. Cheers. Bye-bye.